Welcome everyone to the introductions to the quality engineering. This is what we'll be discussing in today's video. Quality has only two point of views. One is confirmations of the requirements, which is absence of defect, or should I say narrow definition, sometimes referred to as quality Q. Fitness for use. The second version is relative to the needs. Broader definition referred as big Q, capital Q, relatively to the actual requirements, needs, not just written requirements. Includes other attributes, product quality, project business objective, and organizational effectiveness. So yes, two quality views: confirmation to the requirement, which is abstract, which is absolutely pure, ideal situation, and fitness first for you, relative to the needs. So there are two things which may not be ideal, but probably you can still manage the show for the time being. So quality engineering is to optimize quality, not to maximize. Optimize as far inputs and outputs are quantified. Preferred trade-offs among multiple objectives. Example, achieve desired quality levels with cost bound, as the case might be. Aim is to design system and systematic approach that continually work towards the optimum results. Limitation of quality engineering. Quality framework defines what to do and how to do, measures the outcome thereby. They can identify, even eliminate problem. So quality framework is very, very straightforward. But their effectiveness depends on the people who do the activities. So framework is good. Everything is mandated, but then it is the people who are going to work upon it is corrupt, right? And their attitude determines the limitations. Framework cannot be delivered, cannot deliver excellence. Only people like you and me, or people who are going to man the position, can deliver excellences. Processes, it is systematic steps for completion of a task. It might be completely structured to getting things done. The best process of task is that what accomplishes the task most effectively, quickly, fastly, and in a cost-effective fashion, optimizing the optimize across task objectives. What are we looking into it? Are we going to have more, and more process, or just the best process? Process maximization probability of successful task accomplishment. That is to prevent problem. More process is more formality, improve probability of success, but runs counter to the objective in terms of cost, in terms of flexibility. Best process optimizes across task objective, hence more process is not always good. This is what you need to understand. More of a bureaucracy can always delay the work altogether. Less of a bureaucracy, at the same time ensuring all records have been maintained, enhances or optimizes production process thereby. So you need to understand what is the more process and what is the best process. Process design, designing a good process requires understanding of various objective, task objective. I'm saying process, activities, task objective, absolutely. Understanding the impact of steps involved, process design decisions on all the different objectives. Creatively identifying different possible approaches and picking the best. A typical engineering design format, as the case might be. Processes are designed to prevent problems, reduce variances to output. Process are not free. There is a cost in time, there's a cost in effort, as well as flexibility. Processes incorporate assumption about the nature of the task and about the objective. But in every situation, it is a little wee bit different. The more the difference, the less effective the process is all about it. Process customization is not free. Remember, this is what needs to be understood. Tailoring the processes, tailor-made to the process, is not absolutely free. Metric, the purpose of metric is to provide evaluation, provide feedback. Try walking to the door with your eyes closed. We'll give you a metric. Are you confident of the spatial arrangements? They can provide an objective view to complement the subjective view of the people doing the job. When skillfully used, metrics can reveal long-term trends that are harder to spot otherwise. Filter out random variation. Using metric, problem, we want to compare the prosperity of two communities. We use metric or average per capita income in a city, let's say X is 40% more than the average capital income. Remember, per capita income in a city Y. So which is a richer city? X is a richer city. Conclusion is that conclusion, X is more prosperous place than city. So metrics helps us to understand what is right and what is happening. A limitation of the metrics. Let's say exercise identify reasons as many as possible why conclusion may not be valid. So average per income in a city X is 40% greater than average per capita of income Y. Then Y, therefore X is more prosperous than Y. Probably you need to understand this thing. Now, can we have limitation? Yes, definitely. Yeah. Maybe X is not densely populated. Y as a city is more populated. It is spread over a big area. It's a metropolitan city, whereas the city X is a very small town, perhaps qualifies to be a city, has the infrastructure, but the limitations to the possibilities. The see the differences. Now, this is where it happens. The metric design, follow-up exercise. If you want to determine which city is more prosperous, use metric-based approaches. What and how to go about it. The interpretation, moral of the story, metrics tells us something. But to make sure that the number don't mislead us, we need to do a lot of additional work behind the scene. Does this requires metric understanding? Yes, definitely. Does it requires domain understanding? Very much. Did I say the concept X being more prosperous since 40% of the per capita income is much more higher? But when I change the perspective that the city Y is more populous, you think the domain changes altogether. Familiarity or city Y produces more part of a GDP than city X. It might have a higher number of billionaires, but city Y generates more GDP. So, depending upon it, familiarity with the specifics of the situation is more important. Doing this is all about metric interpretation. Any chart should be accompanied by comments that points out what lies behind the number. That is a rule at Motorola. This is the real value added to the quality engineers. Famous lines about metric. There are only three kinds of lies. Three kinds of lies. Damned lies and statistics. Lies, damned lies, and statistics. Statistics can be presented in the fashion you want it to be looking around it. What statistics reveal is something very interesting. What they conceal is very, very vital per se. Another famous line, if you cannot measure it, you cannot control it. The idea is measurement helps to close the feedback loop. What is required? Flip side, if you manage purely by numbers, all you manage is nothing but just the numbers. Objectives that are not measured will never be met. And some of them may be more important one. And as we have seen, numbers don't reveal the entire truth. To ponder is the goal, to control is the outcome. On to facilitate achievement of better outcome per se. As a concluding remark, quality engineering is all about effectiveness. It is all about effective ways to achieve the project objective. Processes, metrics are enabler for this. Defining good processes, selecting good metric is a challenging design problem. Metric interpretation is absolutely critical. With this, I come to an end of this video. Thank you for watching this video till the end.